Okay, now we're going to look at graphing compound inequalities. And a compound math problem is similar to a compound sentence in English class. It's one that uses the word and or to combine two things. In math class, it's a little different how you think about them though. And means we want to have both situations occurring. When we get down to an or problem, it means you'll take either. Okay, you will take anything that's there. So we're going to graph each of these separately. So the first one, x is greater than -2, I'm going to graph on the top row. So here's -2. It is open circle because it's just greater than, and this direction is greater than. Then we're going to graph the second one here in the middle row. So x is greater than or equal to 1. Here's 1. Equal to means we're closing that bubble in. Greater than is the same direction. Now, if we were to take what they have in common, we want to have both greater than -2 and greater than or equal to 1. Where they are both in common, if we kind of smush these together, where there would be double shading would be from the 1 up, including the 1 because 1 is included up here, and that would be your final answer. Okay, it's not always the second one necessarily. You're looking for where they have the same stuff, both shaded. All right, this next problem is an example of an and problem, but it doesn't have the word and in there. This can be translated into x is greater than or equal to the -1 and x is less than 2. So I'm going to rewrite that. X is greater than or equal to -1 and x is less than 2. So we're going to graph the x greater than or equal to -1. Here's -1. Greater than or equal to is colored in. X less than 2, that's going to be an open circle. Less than goes the opposite direction. Now remember, I said for an and statement, we want to see where both things have shading, where both things have answers and solutions. So if we press these two together, we would have double shading in between here. So we're going to have an open circle, a closed circle at the -1. We have an open circle out here at the 2, and we have everything in between there as our answers, including the -1, but not including the 2. Okay, so this is our final answer. Now, for the last problem, change it up to an or problem. Or means pretty much I'll take anything that's shaded. So if I graph x is greater than 0, x is less than 0, whoops, less than goes this way, and x is greater than 2, my final answer is going to be anywhere there's shading has to be down in my answer. So I have shading here, and I have shading out here. So if you smash this together, anywhere there's shading is going to be in your answer. Okay, so anywhere for an or statement. And again, this is our final answer down here.